In this video, since this is our last video, we're just going to finish up talking about quadratic equations and using the quadratic formula to solve them. So as a reminder, quadratic equations are simply equations that you can take the form ax squared plus bx plus c equals 0. Now, the key to quadratics is that they have a square in them. Square is the largest term. Okay, there's no cubes, and if there's anything smaller, it would be considered a linear equation. So quadratics, x squared, that's what you're looking for there. Now there's different ways to solve quadratic equations, figure out what the value of x is for things that look like this. However, in this video, we're just going to talk about the quadratic formula to solve quadratics. And you're going to come up with two different solutions using the quadratic formula. And how you do that, even though it looks like you're just going to get one answer, is that this little plus or minus there. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So you may not have that memorized. That's okay. Just have it handy. There's a fun little video on the course announcements this week that you should check out in case you're feeling like you're unsure about the formula. But we're going to use this to figure out what the value of x is. So let's go ahead and get started with our first quadratic. We know it's quadratic because there's an x squared, and that's the largest variable, or exponent, sorry. Largest exponent is a 2. So it is in the correct form because you have all of your terms on the left-hand side and it's set equal to 0. So we can just look at our coefficients and label them. The first one is always a, the second one is b, and the third one is c. Notice that b is negative and c is negative as well. So b is negative 3, c is negative 10. Now we can just use our formula, handy dandy formula, to plug this in. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't have this memorized, it's a good idea to keep rewriting it. That's a way to help yourself remember the formula. So negative b is already negative. So a negative being negated is actually a positive. So negative b, since it's already negative 3, will be positive 3 plus or minus square root of b squared. So that's going to be negative 3 squared. Since you're squaring the negative, it turns into a positive. Just a heads up. So minus 4a, a is 4, and c is negative 10. All over 2 times a. 2 times a is 4. Now, I'm kind of lazy and I don't like to rewrite things a bazillion times. So I'm just going to go ahead and simplify this square root over on the side. So negative 3 squared is going to be 9 minus 4 times negative 10. If you have a scientific calculator, you can just type it all in, and you'll see you get 169. Oops. Did not mean to do that. So 169, which is a perfect square. And the perfect square is 13. 13 squared is 169. So we can go ahead and actually rewrite this as 3 plus or minus 13 all over 2 times 4, which is 8. Now, we don't have anything else to simplify right now, so why don't we go ahead and just split it into two solutions, one where I'm adding the top and one where I'm subtracting. So on the top, let's do addition first. So 3 plus 13 is 16 over 8, which is 2. So we have our first solution for x, which is 2. And then on the bottom, 3 minus 13 is going to be a negative 10 over 8, which isn't as perfect. So negative 5/4 or negative 1.25. So you can see x is equal to these two values. And they're two real solutions, which is nice. And we'll learn later on, but this is going to help us to draw our quadratic into a parabola. And those x's will be where they intercepting your x-axis, which will be nice. So just keep that in mind. That's what we're actually solving for. Okay, now let's try one more using the quadratic formula. Now notice this one is not in the correct format. It's not in standard form. So we need to move things to set it equal to 0. So I actually like to make whatever, if your leading coefficient, the coefficient in front of x squared is a negative, let's make it positive by just moving it to the right. So this actually can be rewritten as 6x squared plus 3x plus 2 equals 0. Just move that to the other side, set it equal to 0, and then switch the sides. Okay, so now we can label. Let's go ahead and label. Just kidding, we're not switching yet. I know you were excited. Okay, so 6 is our A, positive 3 is our B, and 2 is our C. So we're going to go ahead and use x equals negative b, so that would be negative 3. Since it's currently positive, flip the sign. Plus or minus the square root of b squared, 3 squared, minus 4 times 6 times 2, all over 2a. So as we talked about before, I like to go ahead and just simplify the square root first. So 3 squared is 9 minus 4 times 6 times 2, which is negative 39. Now, just as a reminder, whenever you have a negative underneath the square root, you can pull it out and turn it into an I and make it imaginary. So this actually turns into I times the square root of 39. Now 39, if I'm not mistaken, is only divisible by 3 and 13, which are prime numbers. It's not divisible by any perfect squares, so we can't reduce the square root of 39 at all. So as we rewrite this, it's going to be negative 3 plus or minus I times the square root of 39 all over. Oh, I forgot to put a in here. I was just like, oh, it's just going to be a. A is 6. So 2 times 6 is 12. And for this one, this is an imaginary solution. So we do not have to simplify it any further. There's nothing we can reduce because this does not have a coefficient that we could divide with 12. So that's it. We're done solving for this problem. This is an imaginary solution. Basically, it lets you know that your parabola is never going to cross the x-axis. So, but we'll learn more about that later. Don't want to get ahead of ourselves. I do have one last problem that we're going to go over. And that last problem is a word problem because that's a great way to wrap up this week's problem. And we're going to use the quadratic equation to help us out with this one. So a parking lot has a rectangular area of 40,000 square yards. The length is 200 yards more than twice the width. So some of that terminology that we've used before. What are the dimensions of the lot? So whenever you have area or perimeter or anything like that, I like to draw a nice little picture. You can make it super fancy, draw little cars in there, flowers, whatever you want to do. But we know the area is equal to 40,000 yards. And since this is a rectangle, what is that? I don't know. The area of a rectangle is length times width. So that's going to help us out as well. Length times width. The length is 200 yards more than twice the width. So we don't know the width. Let's call it W. But I know the length is going to be 200 yards more than. More than means addition. So I'm just going to go ahead and add 200 to whatever twice the width is. Twice implies that you're multiplying by 2. So 2W plus 200. So remember those keywords. Go back to that. In the course announcements, I give you that hint for all those keywords. So now we have the length and we have the width. They want to know the dimensions. So let's combine these two. So area equals length times width. Area is also equal to 40,000. So the length is going to be 2W plus 200. And I'm going to multiply it by the width, which is just W because I don't know what the width is right now. But I know that the length times width should be equal to area, which is 40,000. So let's go ahead and simplify this and then solve for our values. So first thing we need to do, let's go ahead and distribute that guy. So 2W squared, oh no, it's quadratic because it's got a square, plus 200W equals 40,000. Now, is this in standard form? That's what you need to ask yourself. Well, right now, it's not because it's not set equal to 0. So let's go ahead and subtract over that 40,000. So 2W squared plus 200W minus 40,000 equals 0. We have our quadratic equation in standard form. It's got that square over there. Everything's on the left. Now we can use our quadratic equation to help solve. Now you could factor out a 2, but let's not worry about that. Let's go ahead and just use our quadratic. X equals negative b, so negative 200 plus or minus. If you wanted to know, this is going to be A, this is going to be B, and this is going to be C. Okay, b squared, so 200 squared minus 4 times A times C, which is a negative 40,000. I can fit it. Yay! All over 2A, 2 times 2. And then we simplify. So negative 200 plus or minus. Let's see what that square root simplifies to. So 200 squared minus 4 times 2 times negative 40,000. Make sure I got enough zeros on there. So it's the square root of 360,000 all over 4. What is the square root of that number? 600! Yay! Simplifies down quite nicely. So negative 200 plus or minus 600 all over 4. And remember we talked about the fact that we have to split this into 2 solutions. So let's do the addition one first. So negative 200 plus 600 is going to give you 400 divided by 4 would be a nice 100. And then let's do the subtraction. So negative 200 minus 600, negative 800 divided by 4 is going to be negative. Ignore that. Negative 200. Now, x is actually our variable, which is w. So I could actually change that to a nice little w. So it says w is either 100 or negative 200. What's the problem with negative 200? It's not a real world solution, right? We don't have negative lengths. So instead, we're going to say, okay, well, this negative 200 is not going to work, so let's pick that 100. My width is 100, but that's not all I need to know. Did you go back to your question? What are the dimensions? So I need to know both the width and the length. So let's go ahead and figure out my length. It's 2W. 2 times 100 is 200 plus 200, 400. So let's double check that gives us 40,000. 400 times 100, you betcha, when I multiply those two, I do get 40,000 square yards. And actually, we don't want to forget our dimensions, right? Our units. Those are very important, right? So that would be your dimension. So you just share those 2 units for your dimension. So keep working on that quadratic formula. It's going to come back for us later on. So good luck.